Welcome to the Analog Design Flow video for SmartFusion. This video will show you how to create a SmartFusion project in Libero IDE and configure the analog compute engine, otherwise known as the ACE, within the SmartFusion microcontroller subsystem to complete the FPGA hardware design. Open the Libero IDE New Project Wizard, name the project Voltage Monitor, select the HDL type as VHDL, and click Next. Select SmartFusion A2F200M3F 484 FPGA as the family, die, and package type, and click Next. Confirm or edit the integrated tool profiles and click Next. For this project, we will not be importing any external files, so click Next and review all the selections made. Click Finish to create the project. Since SmartFusion has been selected as the FPGA family, the Add Microcontroller Subsystem dialog opens. The SmartFusion Microcontroller Subsystem MSS core name and version number will be showing in the window. Enter a name such as Voltage Monitor MSS into the design name window and click OK. The Smart Design MSS configurator opens. Note that the Libero IDE's Smart Design MSS configurator closely resembles the SmartFusion block diagram in the datasheet. The Smart Design MSS contains a number of representative peripheral images that are actually configurable software interfaces that determine the functionality of your SmartFusion design. Note that the Smart Design MSS configurator has different colored blocks. The blue blocks are for hardware configuration, the orange blocks are for firmware configuration and are only configurable in the software flow. Green blocks are not configurable, and any gray blocks are disabled. Blocks that have a small checkbox in the bottom right corner can be disabled in order to conserve FPGA resources and power. Hardware blocks can be opened for configuration by clicking the wrench icon in the bottom right corner. This voltage monitor design only uses clock management, ACE, UART0, and GPIO peripherals. All other peripherals must be turned off by unchecking the checkmark in the bottom right corner of the peripheral. Double-click or click the wrench icon on the MSS Clock Management configurator located in the top left corner of the MSS and select the following settings. On-chip RC oscillator as the clock input. Select PLL output of 80 MHz. Select fab clock, A clock, P clock 0, and P clock 1 to divide by 2 to equal 40 MHz. Click to OK the MSS Clock configurator. Next, double-click or click the wrench on the ACE configurator. This design uses the TM0 input pin of the SmartFusion FPGA. TM0 drives the signal conditioning block 0 analog to digital converter input. TM0 is connected to the potentiometer of the SmartFusion evaluation board, which will be used to vary the voltage monitored by the SmartFusion device. On the Configure ACE dialog, select the ADC direct input and click Add in the Add Service window. Leave all other default settings and click OK. The Configure ADC direct input dialog opens. In this dialog, enter TM0 voltage as the voltage name and input 10 microseconds as the acquisition time. The threshold detection window enables you to create the flag voltage levels that send signals to the evaluation board LEDs when the voltage thresholds are reached. Enter the following into the threshold detection window. Flag name over 1P0V. Flag type is over. Threshold 1.0. Hysteresis 25. Flag name over 1P5V. Flag type over, threshold 1.5, hysteresis 25. Flag name over 2P0V. Flag type over, threshold 2.0, hysteresis 25. Flag name over 2P5V. Flag type over, threshold 2.5, hysteresis 25. Accept all other settings on the dialog and click OK. This closes the Configure ADC Direct Input dialog. Next, going back to the Configure ACE dialog, click the pull-down on the Packaged Pin column and select pin W8. which is the package pin for the TM0 signal conditioning block 0 input. Now click the Controller tab of the Configure ACE dialog to set up the sampling sequence. The Controller tab opens and lists the ADC0 main and ADC1 main sequence procedures. Click the Insert Operating Sequence Slot button on the Details of Procedure window and select Sample. The Configure Sample window opens. Use the pull-down and select TM0 voltage and click OK. Click the Insert Operating Sequence Slot button again and select Restart Sequence. This sequence keeps a continuous sampling sequence in operation. Now, click the Flags tab on the Configure ACE dialog. This tab lists the interrupt sets from the PPE post-processing engine registers. Click the plus sign to expand the flag registers group. The PPE flags registers contain the user-defined flags. Select PPE flags 0, flag bank 0, and observe that the PPE flag 0 contains the 4 threshold flags assigned earlier. These are the flags that were defined when the direct input voltage service was configured. The flag register is read by the ARM Cortex-M3 processor. The flags also generate interrupts to the Cortex-M3 processor. Click OK to close the ACE configurator. Next, you will configure the GPIO peripheral in the MSS. Click the wrench icon in the bottom right corner of the GPIO block. This opens the GPIO configurator. This design requires GPIO 27, GPIO 26, GPIO 25, and GPIO 24 to be connected to LEDs 1, 2, 3, and 4 on the evaluation board. Changing these ports to outputs in the configurator will route them through the SmartFusion fabric so they can be assigned to external pins on the SmartFusion device. Click OK to close the GPIO configurator. Then, on the MSS, highlight ports 24, 25, 26, and 27 on the GPIO block, right-click, and select Promote to Top Level, which really means next level up in the hierarchy. You will assign these ports to a top-level package pin later. Now, click the Firmware tab at the top of the Smart Design MSS configurator. The Firmware tab provides a view of all firmware that should or could be required for the design. For this design, you do not need the Watchdog, Timer, NVM, PDMA, HAL, or UART1 drivers, so they can all be unchecked. Note that if the core type names are displayed with italicized font in the firmware catalog, this means that the firmware cores have not been downloaded from the Actel IP repository to your local drive. If you have an internet connection, you can right-click on the core type name and select to download the core. By default, the IP and firmware cores are downloaded into an Actel folder on your C drive. Click the gear wrench icon on the SmartFusion CM-SIS PAL 0 to select Actel's Soft Console as the software IDE tool that will create and debug the embedded software. You can also select Keil MDK or IAR Systems Embedded Workbench for other projects. The Smart Design MSS also includes an I/O editor. Click the I/O editor tab at the top to view the MSS I/Os and their respective attributes. Some attributes are configurable. At this point, you are finished with the configuration of the MSS. Click the Generate icon in the toolbar. MSS generation may take a few seconds. It is completed when you see the Design Voltage Monitor MSS was successfully generated message come up. Click OK. Save and close the MSS.